Hello everyone. So right before us here is a beautiful integral from MIT, and then here we have the integral from negative pi to positive pi of sine of 2025x cosine of 2026x dx. So how do we work this out? Well, to begin, notice that the interval is symmetric. It's symmetric in the sense that if you have a negative pi, then you have a 0 and then you have a pi. So these are the cases whereby we see the interval is symmetric because the distance from the negative to the 0 equals distance from the positive to the 0 part. So here we have a case of symmetric interval. And the case of symmetric interval, what happens? Well, it says that the integral from negative a to positive a would equal of f of x dx would equal two things. It would be 0 if on the case of when f of x is odd. So if f of x is odd, this would be 0, and it will be equals to twice the integral from 0 to a of f of x dx if f of x is even. So if f of x is even, so if this function is even, instead of computing from this interval and then this interval, you can just take only this interval and multiply the result by 2. So that is what it means. And because we know that even function, they are more like reflection along the x-axis, while odd functions are reflection along the y-axis. So for odd function, you should get something like this. So it's more like a reflection along the y-axis. So in this case, the area on this side and the area on this side, they would cancel out and the result will be 0. Whereas for even function, it's more like you have this. So this function is even. So it's something like this. So it's more like the area on this side would be the same thing as the area on this side. So they would both be equal. So we need to only check if this is even. Don't worry about the dates at the top, 2025 and 2026. They are basically just there to throw you off balance. So what we need to worry about is if this function being f of x equals to sine of 2025 x times the cosine of 2026x, we need to worry if this function is even or odd. Now let's check it out. Take x to be negative x, so you have f of negative x would be, for the sine case, because the power is odd, you have a negative sine. Okay, let me just say you have a sine to the 2025 of negative x times the cosine of 2026 of negative x. Now because sine of negative x is negative sine of x, and also the power is odd, this will be negative of sine of 2025x times the cosine of 2026x. So because cosine of negative x is basically cosine x, and even so if the power is even, so, and this is basically now going to equal negative f of x. So this means that the function is odd. So essentially this integral would equal to 0. So this is the first problem from the qualifying exam for MIT. So this integral would essentially be 0. Now the next problem for the students is they have to, this is problem 2 from MIT, they have to compute this integral, and may look intimidating because of the date, but you don't need to worry, because first of all, what your mind will be thinking is, okay, let me just do substitution. Let me just take u to be 2026 e to the x plus x. But the problem with this approach is that it's not easy to find the u in terms of dx directly, because then you get something like 2026 e to the x plus 1 dx. It's not easy. Still, this e to the x is very troublesome. So instead, what you need to do is that just do it like this. This is e to the 2026 e to the x. Then this times e to the x. Do it this way, dx. So now you see that if you take u to be e to the x, du would be e to the x dx. So in this case, you will have the integral of e to the 2026 u du, which is basically going to equal, I think you should have 1 over 2026 e to the 2026 u plus c. Yes, that is what you should have, because the integral of e to the ax dx is basically 1 over e to the ax, because if you take derivative of e to the ax, it's going to cancel out with 1 over a. So These are the problem 1 and 2 from MIT, and thank you for watching. In the next video, we're going to do 3 and 4, and so we're going to try to finish tidy up all those problems from MIT. So thank you for watching, and please do subscribe to the channel. Bye.